Chapter 10, 10.1, we are dealing with line segments and intersecting circles today. Please note there is a ton of vocabulary. This is page 280, so a lot of different terms that we will reference, many of which you already know, like I'm assuming you know what a circle is, and what the center of a circle is, and even what a radius and a diameter are. Many of you know what a chord is. We'll talk about that today. And secant, tangent, those are both trig terms, but we will apply them, and you'll actually see what they look like on a circle today. Point of tangency, tangent circles, concentric circles, and common tangent. All things that you can maybe list as you're going through, and if you want to summarize your learning. Okay, so that's page 280. 281 actually lists some of those things out. The reason that you have a page where you do your vocab, remember, and then they give you the actual terms, it's nice if you can go back to this and use it as a study guide. Like if you want to know if you really remember this stuff before you get to the test, or before you get to your quiz, or as you're reviewing for your final, go through and see if you can define those things, and then check your work here. Okay? So, line segments that intersect circles. All right, I want you to read through these right now. This first part here, make any little notes you need, and anything that comes to mind in terms of questions. Okay? On your own, please. All right, go ahead and tell your neighbor a new term that you just read about.
Secant is a line that intersects a circle. 2 points.
Okay, what's the difference between a secant and a chord? Danica? Good. Secant is a line. A chord is just a segment. Perfect. A chord is a part of a secant, right? Okay. So a chord lies on the inside of the circle. It'd be from here to here. Whereas a secant is the line that goes through the circle. Very good definition there. Okay. Notice your tangent. Your tangent hits your circle at one point, and the place where it hits it is called a point of tangency. Okay? Your chord, here's another picture of it, is a diameter a chord?
No.
Definition of a chord, it lies inside and hits the circle in 2 spots. Yeah.
No.
Okay, a diameter is a chord. Okay? And it contains the center of the circle. It's a special chord. All right? All right. Coplanar circles and common tangents. In a plane, 2 circles that intersect in 2 points, 1 point or no points, or they can. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar circles that have a common center are called concentric circles. Okay, 2 points of intersection here. 1 point of intersection, notice these are tangent because they have 1 point of intersection, like a little snowman here. And then no points of intersection can look like this. You could also have concentric circles that have no points of intersection. Okay, a line or a segment that is tangent to 2 coplanar is called a common tangent. So you have your common tangent there. Okay, so just some quick definitions. What I want you to do is take the sheet that that you picked up on the way in. Okay, and you are going to work with your groupies there. I want you to complete example number 1. Oops. And actually, let's just start with example 1, A through D. Okay, let's see if you can do that without looking at your definitions. All right, what is AC? It's a radius. Good. Okay, goes from the center out. What's AB? Diameter. The most specific name is what we want. We could also call it a chord, but more specific is a diameter. What is DE? Tangent. And how about AE? Secant. Okay, and notice this, it's hard to see the arrows there, but those are arrows, meaning it goes through. That's your secant. Okay. Any questions there? All right, I'll let you guys do 1 and 2 on your own later if you'd like. Just a little more there. But example 2, go ahead, work with your groupies, come up with how many common tangents the circles have, draw them in. It says use blue to label external. You can just put an E by the ones that are external and put a I by the ones that are internal. Okay, but draw all those common or those tangents, those common tangents there. These are a bit tougher. If you're doing a tangent, it hits the circle in two spots, or excuse me, one point, but both circles there. Okay, so that would be an external tangent right there, assuming it hits right there. There's another external tangent down here. Okay, those are both external. Are there any internal? Let's see. We can make it hit like that. That would be an internal. Goes in between. Can we do any other internals? Yeah. Yeah, or the, you like mean the reflection type? Kind of like that? Yeah, another internal there. So there are 4 common tangents. Common tangent hits them both. Does this have any internal ones? And where would it be? Yeah, right there. How about external? Only one on the top or up here. Supposed to hit it one spot. There we go. Does this one have any internals in between them? Can we do this? No, what have we drawn there? That would be a secant. It would hit the circle and it would lie inside both circles, but it does have 2 externals. That one has 2. That one had 3. Take a look at 4 and 5. Does number 4 have any? Yeah, I'll tell you it has 1. Go ahead and figure it out, where it would be there. What do you think, Isaac? Good. Right here where the 2 edges meet. Good. And that would be an external. Does number 5 have any? No. What type of circles are those? Concentric. Yeah. Concentric. Good. And then this one would be kind of similar to this one up here. Questions? No. Concentric circles. All right, go ahead and turn over. Example 3. Is ST tangent to P? Well, we didn't talk about this yet, but if a line intersects at a tangent, it intersects at a right angle. In order for that to be a right angle, what would we know about this relationship between these triangles, or these sides? Danica, you have a question about this? Can we come back to that? Yeah. Okay. So what do we know about the relationship of these sides? Cynthia? Good. So we know that a squared plus b squared equals c squared. So that's what we're trying to figure out, if that's a true statement. All right, so let's figure out if that's a right triangle. And if it is, then this would be a right angle. And if that's a right angle, then it's tangent. If it's not a right angle, then it's not tangent. Tangent always hits a radius at a right angle. We'll always intersect the radius of the circle at a right angle. All right, is it? Yeah? 12 squared plus 35 squared. Does that equal 37 squared? The answer is yes, it does. They both equal 13 69. So yes, makes that right angle. Okay, questions on that? So just some quick pieces here. You're going to use these all chapter, okay? No, example 4. Point B is point of tangent C. Find the radius C. The radius of circle C. Okay, work with your partner there. Try to figure that one out. Try to use what we just talked about. It may help you out. All right, using the Pythagorean theorem, because it's a right angle, you'd have 80 squared plus r squared is equal to, what's this side length? Yeah, it's 50 plus r, right? So we'd have to have 50 plus r squared. Well, good thing in our warm-up today we learned or reviewed how to multiply that, right? It's almost like we planned it like that. 6,400 plus r squared is equal to, remember this right here means 50 plus r times 50 plus r. And that's where we do our distributive property, or some of you call that FOIL. But that would give you 2,500 plus 50r plus 50r plus r squared. So if we simplify, subtract r squared from both sides. The r squareds cancel, so you get 6,400 equals 2,500 plus 100r. Subtract 2,500, get 3,900 equals 100r. So r is 39. The radius is 39. Tell your neighbor how you can check your work there and make sure you did it correctly. Yeah? Yeah, just plug it in. See if it works, right? Plug it in there. Okay? It does. I've already checked it. Okay, one last theorem. Sam, question? When I subtract r squared from both sides. That's how the r squared disappeared. Okay? Any other questions there? One last theorem piece here. When you have two, what are these lines called? When you have two tangents originating at the same point and intersecting the same circle, they will be the same length. Therefore, 28 will equal 3x plus 4. So if I'm solving for x here, 28 equals 3x plus 4. So maybe a brief note to yourself, hey, this length is equal to that length. RS is equal to RT. Be nice. 3x equals 24, so x is 8. Hey, 6 through 7, if you'd like to put in a little more practice on any of those concepts on that side that you struggle with, you can do those. I'll put those answers up before you leave today. Any questions? Did any of those other 3 problems there the answers? Please note on number 8, it's plus minus 3 because you take the square root of 9.